So we've seen how to factor different types of polynomials now. We've done GCF with 2 or 3 or 4 or however many terms we want. We've also dealt with grouping, which was specific to 4-term polynomials. But now we're going to look at trinomials. And trinomials, especially ones that don't have a greatest common factor, can be complicated to factor. Some of them are very simple and some of them are very difficult. And there's multiple different techniques based upon the different characteristics of that trinomial. Okay, so that was a long introduction, but it worked, I hope. So we're going to work on factoring trinomials. So the first thing I want to look at is some patterns in the multiplication process. So I'm going to go back and do a multiplication with a couple basic binomials, and then show you how to look at the numbers to separate it, split it back into those original two. So I'll start off with something like x plus 3 times x plus 5. Okay, just a real basic one. Multiplication again. So I'm going to multiply and then show you how to factor or undo the multiplication. So to multiply these, I would again distribute, make sure every term on the left multiplies every term on the right, and so forth. So x times x is x squared, x times 5 is 5x, 3 times x is 3x, and 3 times 5 is 15. Okay, so so that gives us 4 terms, but then there's a common factor, or not common factor, like terms. Man, getting the phrases mixed up here. There are like terms in the middle, and we can combine them. And so I get x squared plus 8x plus 15. Okay. Now what I want to show you is where the numbers, the coefficients, come from in this final answer, so that when we start with this trinomial and work our way back to the factored form, we can kind of pick away at the numbers and try to find where everything lands. Now this works really well when you have an x and an x as your first two terms, because you'll start with an x squared here, right? X times x is x squared. You won't have any like terms to add to it. But watch the other two numbers, the 8 in the middle and the 15 on the end. The 15 comes from the product of 3 and 5, multiplying them. The 8 comes from the sum of 3 and 5, adding them, okay? And so you want two numbers whose product is 15 and whose sum is 8. And that will give you the two numbers to put in the factored form, okay? Another quick example doing the same thing, if I had x minus 7 and x plus 4, for instance. Okay, same sort of idea. If I were to multiply this out, x times x is x squared, x times 4 is 4x, negative 7 times x is negative 7x, negative 7 times 4 is negative 28, and then of course you add the two terms in the middle, which are like terms. You get x squared minus 3x minus 28, okay? And so again, if you look at the first term has just x squared, that's good to 1x squared, so I get 2x, oh sorry, right here, pointing the wrong thing, x and x. Then you also have the negative 28, which is the product of negative 7 and 4, and also negative 3, which is the sum of negative 7 and 4, okay? So always the sum in the middle, the product on the end, and 1 as the leading coefficient, okay? And if you remember that pattern, then you can go through and factor these really in one easy step, okay? So let's take a look at now factoring instead of multiplying. Let's try one like x squared plus 6x plus 8. And so again, remember, as long as you have an x squared on this first term, your final answer, your factored form, will just have an x as each of the first two terms in the final factors. The other two terms, the two constants, are going to come from the 6 and the 8. Remember, you need two numbers that add up to 6 and multiply to 8. Their sum is 6, their product is 8. Now, there's a lot of numbers whose sum is 6, right? 1 and 5, 2 and 4, 3 and 3, -1 and 7, -2 and 8. In fact, I could come up with an infinite number of combinations here. But the factors of 8 are much more limited. They're 1 and 8, 2 and 4. Okay, or you can throw some negatives in there, make it -1, -8. But that's it, they're very limited. And so it's going to be easier to identify the factors first because there's fewer of them, and then choose the right combination that adds up to 6. In our case, 2 and 4, when multiplied make 8, and when added make 6. So 2 and 4 is what we want. And they're both positive, so I'm going to make a +2 and a +4, okay? So x plus 2 and x plus 4 is the factored form. And you could always recheck. Remember, whenever factoring, you can always check your work by multiplying the answer. So if like x times x and x times 4 and 2 times x and 2 times 4, distributing all that out, you should get the original polynomial, okay? Again, you're looking for factors of 8 that add up to 6. Factors of the constant that add up to the middle term, all right? Same idea, we'll do a couple more of these. So x squared minus 12x plus 20. That should work. Again, the x squared at the beginning tells me right off the bat I can put a pair of x's in the first terms of each of those factors. The second terms, the constants, comes from the factor of 20. And we have to find factors of 20 to add up to -12. Okay, so we've got to look at all of our possible combinations of factors for 20. And there's quite a few for 20. It's a little bit tougher one to factor down. 20 has 1 and 20. And maybe I'll run out of space here. Okay, I'll stand on this side. 1 and 20. It also has 2 and 10. It also has 4 and 5. So we have 3 sets of factors. But notice I need them to add up to a -12, not a +12. So I'm going to have to make them all negative to make that work out, right? So negatives on everything. So -1 times -20 is 20. -2 times -10 is 20, so forth. But to get the negative here, I need them to be negative. Now, the only combination that adds up to -12 is -2 and -10. You're never going to find a case where there's multiple combinations that add up to the number in the middle. There's always going to be one. So -2 and -10 will work. So I want x minus 2 and x minus 10 as my two constant terms in the parentheses. Now notice again, if I wanted to check this, x times x is x squared. If I do the outer 2, that's -10x, the inner 2 is -2x, which gives me the -12 when I combine them. And then -2 and -10 makes +20, okay? So that combination is the correct factored form, all right? So again, the sign can be interesting. You can have both of them positive, you can have both of them negative, you can have, here's both positive, here's both negative, you can have one negative, one positive, It all depends upon the signs of the constant and that middle term. Let's try maybe one more. And this time we'll again do some factoring. So let's try x squared minus 7x minus, let me think this one out, 60. Yeah, that's a good one. X squared minus 7x minus 60. Number's a little bit bigger. We've got two negatives in there now. But again, x squared, lead coefficient is 1. So that means my parentheses will have an x in each of the first terms. Okay. Now again, the constants, the second terms in these, is going to come from factors of negative 60 that have to add up to negative 7. Okay, so I'm going to make a list. Now, the 60 has a lot of factors, okay? 20 had a lot, but 60 has even more. So let's go through and make some factors, or make a list of factors, because it's not always super obvious how this will work, okay? So, okay. So let's go through and make a list of factors. It's not always obvious how this is going to work. So negative 60 is my product. I always start with 1 and 60 and then kind of build from there. So 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 8 won't work. So that gives me a lot of factors already. 7 won't work, 8 won't work, 9 won't work, and then 10. So a quick trick to this is if you start at 1, just increase by 1 all the way down. Anytime a number doesn't divide it, you skip it. So like I skipped 7 because 7 doesn't work, 8 doesn't work, 9 doesn't divide 60, and so forth. Once you get to a number on the other side, you've found all the options, okay? So if you go down, starting at 1, keep increasing till you hit a number that's already on the other side, you'll be guaranteed to be done. Now the only problem is when I multiply them, they have to multiply to a negative. So I either have to put the negative on the small side or the big side, and I can choose. I need to choose the big side because when I add them, the 7 in the middle is also negative. So I wouldn't want to put it on the small side because when I add them, I get a positive. So I put them on the big side. Put the negatives on the big side all the way down because I know now that when I add these two together, the bigger one will dominate and I'll get that negative in the middle. Okay? So which combination then gives me negative 7? Well, as I look down the list, that gives me negative 59, negative 28, negative 17, negative 11. This one right here, 5 and negative 12 will add up to negative 7. That's the combination I need to use. So I put those in the parentheses, plus 5, minus 12. Okay, so x plus 5 and x minus 12 will be the correct factored form.